Who created all of this? Some say everything was born from the Big Bang. But then, who triggered the Big Bang? And who brought together 30 trillion cells to form a human being? A creature with intelligence, a beating heart, and consciousness. If there truly is a creator, whether an intelligent God or some invisible law of the universe, where did that creator come from? Was he created by an even higher power? Or has he always existed beyond time itself? To find the answer, humanity has built temples. We have also built telescopes. We searched for God in sacred scriptures. We searched for God in the depths of space. Yet the truth has always seemed just beyond our reach. So close, yet forever unattainable. But what if the answer has been hidden within the universe itself all along? So, over the next 30 minutes, I'm going to bring science and philosophy together and follow one of the greatest questions you have ever wanted answered. That question is, where did all of this truly come from? By the end of this video, I believe your understanding of the universe will rise to an entirely new level. And to uncover the beginning of everything, we have to travel back to Belgium in 1894. That year, a child was born into a Catholic family. His name was Georges Lemaitre. He grew up in an age that held the Bible in one hand and pursued science with the other, driven by faith in God and an endless curiosity about the cosmos. He entered the Catholic University of Leuven, but he was never the kind of man who simply accepted what he was taught. To him, truth, whether discovered in scripture or uncovered through scientific experiments, always pointed to the same ultimate source. To understand the universe was itself an act of worship. As a young man, he studied engineering. He fought in the First World War. Yet the horrors of the battlefield did not destroy his faith. Instead, they deepened his desire to discover the ultimate meaning of existence. So he returned to university, switched his studies to mathematics and physics, and at the same time, entered the seminary, determined to accomplish something few people dared even imagine: to become both a scientist and a priest. It was an era when science and religion regarded one another with deep suspicion. Many scientists believed religion was a chain that restrained free thought. Religion, in turn, had often suppressed scientific inquiry, leaving scars as deep as the trial of Galileo. In such an atmosphere, to suggest that science and faith could peacefully coexist was almost considered heresy. But Lemaitre refused to accept that. He believed science could explain how the universe works, while faith answered why it exists. He had no desire to use science to prove God. Instead, he wanted science to deepen humanity's sense of awe. And it was precisely this conviction that allowed him to see what everyone else had overlooked. In the 1920s, almost all scientists, including Albert Einstein, believed the universe was static, eternal, without a beginning, and requiring no creator. But from the equations of general relativity, Lemaitre saw something different. He saw a universe that was expanding. And if the universe was expanding, then in the past it must have been smaller. Far smaller. So small, in fact, that it could have been compressed into a single, infinitely dense point. That moment would be the birth of the universe itself. A day without a yesterday. To Lemaitre, this idea strangely echoed the book of Genesis. In the beginning, God created the heavens and the earth. In 1927, he published a paper proposing that the universe is expanding, and that it originated from an explosive beginning. The theory immediately caused controversy. Some accused him of secretly inserting theology into physics. Even Einstein reportedly told him, "Your calculations are correct, but your physics is atrocious." Because to accept a beginning of the universe was to accept that everything came into existence from nothing. And that made many scientists deeply uncomfortable. To many, Lemaitre's idea felt like a crack in the wall of secular cosmology, a door opening toward theology. But he did not retreat. Instead, he refined his equations, gathered more evidence, and strengthened his mathematical model. Then, in 1929, everything changed. The American astronomer Edwin Hubble observed that galaxies were moving away from each other. The universe was indeed expanding. This observation became a decisive confirmation of Lemaitre's theory. From that moment on, science was forced to seriously reconsider his idea. The term Big Bang was originally coined by Fred Hoyle as a mockery, but the name remained. And over time, the evidence began to accumulate. By the mid-20th century, the Big Bang model had become the dominant explanation for the origin of the universe. For Lemaitre, this was not just a scientific victory, it was also a confirmation of his deepest conviction that science and faith could illuminate one another. He never used the Big Bang as proof of God. Instead, he treated it as a way to contemplate the grandeur of creation. He always maintained a clear boundary between science and theology, yet he also admitted that this discovery deepened his sense of spiritual resonance. Fast forward nearly 40 years. A young Stephen Hawking stands at Cambridge University, defending his doctoral thesis. The question remains the same, one that has troubled thinkers for centuries. Where did the universe come from? But Hawking would take a very different path from Lemaitre. Decades later, he would propose the no-boundary proposal, a radical reinterpretation of the universe's beginning that challenged the very idea of a creator. In 1963, at just 21 years old, Hawking was diagnosed with ALS, amyotrophic lateral sclerosis. Doctors predicted he had only a few years to live, but he survived and went on to reshape humanity's understanding of the cosmos. At that time, he married Jane Wilde, a devout Christian, whose faith helped sustain them through the darkest years. But as his scientific career progressed, Hawking's rejection of religious belief became stronger. By the 1980s, he had fully embraced the idea that the universe could be explained without any need for a creator. The no-boundary proposal was his most ambitious attempt. According to general relativity, gravity is the curvature of spacetime, caused by mass and energy. Under extreme conditions, such as near a black hole, or at the instant of the Big Bang, this curvature becomes so extreme that classical physics breaks down. Hawking, already famous for his work on black holes, had discovered that they are not completely black. They emit radiation, now known as Hawking radiation. This insight led him to rethink the beginning of the universe itself. And so he asked, what if the universe had no true beginning at all? Together with James Hartle, he proposed the no-boundary model. The theory was built on the principles of quantum mechanics, and it fundamentally challenged the classical idea that the universe must begin from a single point. In his description, the origin of the universe was not a singularity of infinite density. Instead, it was a smooth, finite geometry. Imagine traveling north from the equator of the Earth. You eventually reach the North Pole. But the North Pole is not a boundary. It is simply the point where north ceases to exist. For Hawking, time behaves in a similar way. At the very beginning of the universe, if you trace time backward far enough, you do not encounter a sharp beginning. Instead, you enter a region where time blends seamlessly with space itself. To describe this, he introduced the concept of imaginary time, treating time as if it were another dimension of space. In this model, the universe has no beginning and no end. It simply is. In a brief history of time, he went even further. If the universe obeys the laws of quantum physics, then it could spontaneously arise from nothing. And if that is true, there is no need for a creator to initiate it. He famously wrote, because there is a law, such as gravity, the universe can and will create itself from nothing. To Hawking, the beauty of this model was its self-sufficiency. A universe governed entirely by physical laws could emerge naturally and inevitably from quantum conditions. But not everyone agreed. Critics pointed out a deeper issue. Where do the laws themselves come from? Why do they exist in such an orderly and precise form? And why do they allow life to exist at all? If the universe is a machine, then even if it runs perfectly, someone must still define the rules. In other words, Hawking may have pushed the mystery back one level, rather than solving it. In 2010, with the publication of The Grand Design, he once again made a statement that shook both science and philosophy. The universe can and will create itself from nothing. At this point, Oxford mathematician and philosopher of science John Lennox stepped forward with a direct challenge. Born in 1943 inches, Northern Ireland, Lennox grew up in a society shaped by both religious and political tension. But his parents were devout Christians who encouraged open discussion between science, philosophy, and faith. His father, a businessman, gave him books from an early age, teaching him to think critically about the world. This background, bridging science and theology, gave Lennox a unique perspective when confronting Hawking's ideas. To him, there was a fundamental flaw in Hawking's reasoning. If the universe truly came from nothing, then where did the laws of physics come from? Because once laws exist, it is no longer nothing. He further argued that physical laws are not self-executing entities. They are descriptions of behavior, not causes of existence. A law like gravity can describe how masses interact, but without matter or space-time, gravity has nothing to act upon. Without a universe, laws are meaningless abstractions. So to treat laws as the origin of the universe is like saying aerodynamics can make a plane assemble itself from nothing. Without engineers, without materials, and without a factory. Laws describe what happens under conditions, but they cannot create the conditions themselves. From his perspective, Hawking's no-boundary proposal, while mathematically elegant, still depends on a pre-existing quantum framework and the laws that govern it. It may have avoided the question of a beginning, but it did not escape the deeper question. Where did the framework itself come from? Reducing the origin of the universe to quantum fluctuations only shifts the mystery one step backward. Why does the wave function exist at all? Who determined its form? This leads to an infinite regress. Each explanation requires a deeper foundation, and that foundation requires another explanation in turn. If the universe emerged from a quantum vacuum, then we must still ask, where did the laws governing that vacuum originate? If those laws are taken as given, then they themselves become the mystery. For Lennox, the only coherent answer is that the explanation must lie beyond nature itself. His argument also touches one of the most fundamental principles in philosophy, the principle of causality. Everything that begins to exist must have a cause. Hawking suggests that the universe could create itself, but Lennox argues that this is logically incoherent. It is equivalent to claiming that something exists before it exists. To make this clearer, he often uses a famous German tale, The Absurd Adventure of Baron Munchausen. In the story, the Baron finds himself trapped in a swamp, sinking deeper and deeper, with no one around to help. In desperation, he grabs his own hair and pulls himself and even his horse out of the swamp. We laugh at the story because we immediately recognize the absurdity. You cannot lift yourself out of a swamp by pulling your own hair. There is no leverage, no external force, no independent support. This is the problem of self-causation. If the universe truly created itself, it would be like pulling itself out of non-existence by its own bootstraps. It sounds imaginative, but logically, it collapses under scrutiny. For anything to act as a cause, it must already exist. If we take the idea of self-creation seriously, it leads us into a conceptual dead end. And if we examine the meaning of nothing more carefully, the problem becomes even sharper. This is not empty space, nor a silent void filled with potential. It is absolute nothingness. No space, no time, no energy, no laws, and no structure. In such a state, nothing can happen at all, because there is no stage upon which anything could occur. To claim that a universe can emerge from such a state is to assume a miracle without a mechanism. It requires a cause beyond the system itself, something not bound by the universe, yet responsible for its existence. In philosophy, this is often referred to as the unmoved mover, a concept dating back to Aristotle, and later developed into the idea of a necessary being. Unlike everything else, this being does not depend on anything else for its existence. It simply is the ultimate source of all that exists. From this perspective, the universe is not a closed system, capable of fully explaining itself. Instead, It points towards something beyond itself. A deeper layer of reality. The remarkable precision of physical laws. The fine-tuning of constants. And the very fact that the universe is intelligible to human minds. All seem to suggest a deeper order underlying everything. Consider the conditions required for life. If the gravitational constant were slightly stronger, stars would burn out too quickly for life to emerge. If it were weaker, stars would never ignite at all. If the electromagnetic force were even slightly different, atoms could not form stable structures, and chemistry, as we know it, would not exist. If the ratio between protons and neutrons were altered, carbon and oxygen, the building blocks of life, would never be produced. The expansion rate of the universe, governed by the cosmological constant, is also astonishingly precise. If it were faster, matter would never clump together. If it were slower, the universe would collapse back on itself. The precision required is so extreme that it has been compared to balancing on a razor's edge, with a probability of deviation as small as 1 part in 10 to the power of 120. Even the relative strengths of the fundamental forces must fall within an incredibly narrow range. Otherwise, either atoms would fall apart, or stars would burn out too quickly for life to exist. These delicate balances raise a profound question. Is this universe truly the result of pure chance? Or does such precision point towards something deeper? This is what scientists call the fine-tuning problem. For decades, it has troubled physicists and philosophers alike. Some, like Max Tegmark, propose that our universe may be just one of many. A multiverse, where each universe has different physical laws. But even this idea does not eliminate the question: why does the multiverse exist at all? And why does it generate such structured possibilities? Doesn't the existence of such improbable order suggest something beyond randomness, perhaps even intentional design? British astronomer Royal Martin Rees has noted that the emergence of life depends on extremely specific conditions. Many physicists, including him, acknowledge that fine-tuning is difficult to dismiss as mere coincidence. Paul Davies goes even further, suggesting that the laws of physics themselves may not be arbitrary, but the product of a deeper underlying intelligence. The universe does not merely allow life. It appears calibrated for it, with astonishing precision. And that leads some to conclude that there may be a designing mind behind the cosmos, a mind that not only initiated the universe, but also set its fundamental rules. In genetics, the voice of Francis Collins is equally striking. As the leader of the Human Genome Project, he helped map the complete blueprint of human DNA. Yet outside the laboratory, he is also a devout Christian, openly speaking about the compatibility between faith and science. To him, the structure of DNA, the complexity of life, and the delicate balance of physical laws are not products of blind chance. They are signatures left by a creator. From Roger Penrose to George Ellis, many leading scientists have acknowledged that the precision of the universe's constants appears almost beyond comprehension. Penrose himself has argued that the probability of such an ordered universe arising by chance is so small that it is almost inconceivable. It is like a perfectly engineered timepiece, one that inevitably suggests a watchmaker. In the same way, the laws and constants of the universe seem to imply a designer who not only set them in motion, but also defined their precise structure. But this raises a deeper question. If the universe requires a creator, then who created the creator? And where did that intelligence itself come from? At the Bodleian Library in Oxford, Alister McGrath is often seen walking between the shelves. Once an atheist, he is now a theologian and historian of science, spending much of his life reflecting on the intersection of science and faith. His scientific training taught him to question everything. But when he entered the deeper waters of theology, he encountered a persistent and unsettling problem. If God created the universe, then who created God? This is the classic problem of infinite regress. McGrath begins by dissecting its logical structure. At its core lies the principle of causality, a foundation of both philosophy and science. Every effect must have a cause, and every cause leads to another effect. This is how we understand the world, from atomic motion to the formation of galaxies. But when we apply this principle to the origin of the universe itself, a difficulty emerges. Imagine a game of billiards. The cue ball strikes the first ball, which strikes the second, which strikes the third. A chain of cause and effect that is easy to understand. We trace it back step by step. The cue ball moved because it was struck. The cue stick moved because of your arm. Your arm moved because of muscle contraction, and so on. But if we continue asking, why? We find that every cause requires a prior cause. The question then becomes, does this chain extend infinitely backward, never reaching a true beginning? Or must it stop somewhere? If every motion on the table depends on another, then nothing is ever truly initiated. In an infinite regress, the origin disappears entirely. And when we extend this logic to the universe itself, to stars, galaxies, and cosmic evolution, we are left with the same problem. If every event requires a prior cause, then where is the first cause? What initiated existence itself? According to strict causality, everything should have an explanation. But if every explanation depends on another, we are trapped in an endless loop, with no ultimate foundation. McGrath recognizes that this problem challenges both worldviews. For atheists, he asks, if the Big Bang is the beginning, what caused it? And what caused the conditions before it? For theists, he asks, if God created the universe, then who created God? These questions seem reasonable, yet they reveal a limitation in human thinking. We are accustomed to reasoning within time and space. It is difficult to imagine existence beyond those dimensions. To resolve this, McGrath turns to the concept of a necessary being. Across classical philosophy and theology, there has been the idea that not everything requires a cause. Most things in the universe are contingent. Trees depend on sunlight, planets depend on gravity, and physical systems depend on laws. But a necessary being is different. It does not depend on anything else for its existence. It is self-existent, the ultimate foundation of reality. Many theologians identify this being as God. Unlike contingent things, God does not rely on external causes. He simply exists, eternally and independently. This idea offers a stopping point to the problem of infinite regress. For McGrath, its appeal is not that it removes mystery, but that it provides a coherent endpoint to an otherwise endless chain of explanations. Mathematics accepts axioms that cannot be proven, but are necessary for the system to function. Theology, in a similar way, treats God as a foundational axiom of existence. Science itself contains similar examples. The laws of thermodynamics describe fundamental constraints on energy and entropy, yet they are not derived from deeper principles. They are simply accepted as foundational. In mathematics, zero and infinity cannot be fully explained, yet they are indispensable to understanding quantity. These examples remind us that some foundational truths may exist beyond derivation. Time itself also raises questions. If we imagine an infinite regression of events into the past, we encounter a problem. Modern cosmology suggests that time itself had a beginning, the Big Bang. If time itself began at that moment, then causality as we understand it may not apply before it. This aligns with the theological idea that God exists outside of time, creating both space and time itself. When McGrath combines these ideas, he concludes that the question, who created God, may be fundamentally flawed. It assumes that God exists within the same framework of time and space as the universe. But if God is the source of that framework, then the question is like asking, what is north of the North Pole? It begins from a misunderstanding. As Scripture states, in him all things were created, things in heaven and on earth, visible and invisible. All things were created through him and for him. He is before all things, and in him all things hold together. However, this view is not without criticism. Some argue that invoking a uncaused cause does not solve the problem, but merely renames it. Why stop the chain at God instead of at the universe itself? This perspective is common in naturalism, which holds that the universe and its laws are self-sufficient. David Hume famously questioned whether we are justified in extending causality beyond the limits of human experience. We have never observed the creation of a universe, so any claim about its origin, religious or scientific, remains speculative. Others argue that causality itself may not apply at the level of quantum physics, where certain events appear to occur without deterministic causes. If causality breaks down at fundamental levels, it may not govern the origin of the universe either. Criticism of the infinite regress argument does not stop at logic alone. Some objections come directly from cosmology. For example, the multiverse hypothesis suggests that our universe is just one of many, possibly infinite universes, each with different physical laws and constants. In such a framework, there may be no single beginning at all. Instead, universes could continuously emerge through processes beyond our observable horizon. Other physicists and philosophers have proposed cyclic models of the universe in which cosmic expansion and contraction repeat endlessly over time. In this view, there is no first moment, no ultimate origin, only an eternal cycle of rebirth and collapse. These ideas suggest that the universe may be self-sustaining, without the need for an external starting point. Critics of the cosmological argument also point out that our understanding of causality is rooted in experiences within time and space. But if the universe originated from a state where time and space did not yet exist, then causality itself may not apply. This undermines one of the core assumptions behind the argument for a necessary first cause. From a naturalistic perspective, the idea of God is often seen as a gap filler, an explanation used for what science has not yet explained. Historically, phenomena such as lightning, disease, and planetary motion were once attributed to divine action. But over time, science replaced these explanations with natural laws. Critics argue that the origin of the universe may eventually follow the same path. Nevertheless, supporters of the theistic view maintain that it provides a coherent and complete framework for understanding existence. They acknowledge the strength of scientific objections, but argue that alternative explanations, such as the multiverse, remain unverified. And in the absence of empirical evidence, they believe the question of ultimate origin remains open. However, there is a deeper assumption underlying the entire debate, that if God exists, he must be a personal, conscious being, a kind of superhuman agent, only infinitely more powerful. But what if that assumption is wrong? What if God, or ultimate reality, is not a person at all, but rather a fundamental principle of existence itself? This shift in perspective leads to a very different understanding of divinity, one that moves beyond personality, beyond intention, and beyond agency. In this view, God is not a being among beings, but the very structure of reality itself. This idea finds one of its most radical expressions in the philosophy of Baruch Spinoza. In 1656, Spinoza was excommunicated from the Jewish community of Amsterdam with a rare and severe decree. He was forbidden from any contact with members of the community, a ban that was permanent and irreversible. After losing his social and religious world, Spinoza lived a modest life, supporting himself by polishing lenses, while devoting himself to philosophy. In this quiet isolation, he developed a radically new understanding of God, nature, and existence. His ideas would later be expressed in works such as Theological Political Treatise and Ethics. The root of his conflict with the Jewish community was not personal dispute, but his philosophical revolution. He rejected the traditional idea of a personal God, a being who intervenes in human affairs, like a divine ruler. Instead, Spinoza argued that God is identical with nature itself. God is not outside the universe. God is the universe. In his view, everything that exists, galaxies, stars, laws of physics, matter itself, is an expression of a single infinite substance. There is no separation between creator and creation, because both are one and the same reality. Nature is not a collection of random objects, but a unified, living structure, governed by an underlying rational order. From this perspective, natural laws are not external rules imposed on the universe, but expressions of divine necessity. Gravity, motion, energy, and time are not commands from a distant deity, but manifestations of the same underlying essence. Even consciousness and thought are not separate from this system, but part of its unfolding expression. For Spinoza, everything that exists is part of a single interconnected reality. Nothing stands outside it. Everything is within it. This idea dissolves the gap between the divine and the material world. It also removes the need for a creator in the traditional sense, because existence is self-contained and self-explaining. Nature does not require external design, because nature itself is divine. Although controversial in his time, Spinoza's philosophy would later deeply influence modern thinkers, including Albert Einstein. Einstein famously rejected the idea of a personal God who intervenes in human affairs. Instead, he spoke of a deeper sense of order in the universe. In a 1929 letter, he wrote that he believed in Spinoza's God, the God who reveals himself in the lawful harmony of existence, not in human fate or moral judgment. For Einstein, God was not a personality, but the elegant structure of physical laws. This philosophical vision of Spinoza did not end with him. It was revived and expanded in modern science communication, especially through the work of Carl Sagan. Sagan inherited elements of Spinoza's and Einstein's worldview, seeing the universe as a deeply interconnected whole, governed entirely by natural law, yet filled with astonishing beauty and complexity. In his famous writings, he said, "We are a way for the cosmos to know itself." From this perspective, God is not a supernatural ruler above the universe, but a poetic expression of our deep connection with it. The phrase "we are made of star stuff" is not merely metaphorical. It is literally true. The carbon in our bodies, the oxygen we breathe, and the iron in our blood were all forged in the hearts of ancient stars. This cosmic inheritance binds humanity into the grand story of the universe itself. It also echoes Spinoza's idea that everything is part of a unified whole. Sagan took this further. He suggested that through human consciousness, the universe becomes aware of itself, as if intelligence is not separate from the cosmos, but one of its ways of self-reflection. This gives scientific exploration a deeper philosophical dimension, not just the pursuit of knowledge, but the universe observing itself through us. Perhaps then, all these debates about God, whether as a necessary being, a cosmic designer, or Spinoza's infinite substance, do not ultimately reveal the nature of the universe, but rather reveal something about ourselves. The gods we construct may be reflections of our own minds, attempts to find meaning, order, and belonging in an otherwise silent cosmos. If so, then perhaps what we are truly searching for is not a creator outside the universe, but an understanding of ourselves within it. And this idea brings us to psychology. In a dimly lit room, Carl Jung sits quietly at his desk. A single lamp casts a fragile circle of light into the surrounding darkness. Jung is not just a scientist. He is an explorer of the human psyche, a man who entered the labyrinth of the mind without a map, driven by one persistent question: why do human beings constantly reach for something beyond themselves? Jung believed that the myths and religious stories we create are not random inventions. They are expressions of something far older and far deeper within the human mind. He called these structures archetypes. They exist in what he termed the collective unconscious, a shared layer of the psyche, inherited across generations. These archetypes are not abstract ideas. They are living patterns within us, shaping how we perceive the world and how we search for meaning. Imagine standing on an endless shore. The ocean stretches beyond the horizon, but beneath its surface lies another world, a hidden current of the collective unconscious. It is not chaotic. It has structure, rhythm, and flow. Archetypes move through it like ancient creatures, silent yet powerful, shaping human experience across time. The mother, the hero, the shadow, the self. Jung's insights did not come from abstract speculation alone, but from years of clinical practice. One patient described recurring dreams of a radiant, godlike figure, offering her a golden cup. She could not understand what it meant. Jung interpreted it not as a literal vision, but as a symbolic expression, an archetype emerging from the unconscious. It pointed toward transformation, wholeness, and the human desire to transcend limitation. For Jung, such images were not proof of external gods, but evidence of internal psychological realities. When people speak of God, they are often encountering something within themselves, a symbol of wholeness, meaning, and integration. But does this mean God does not exist? Jung would not say that. He was not interested in proving or disproving God's existence. Instead, he asked a different question. What does the idea of God represent? To him, the divine was a symbol of totality, the integration of all fragmented parts of the psyche into a unified whole. Religious rituals, prayers, and myths are not illusions. They are psychological tools that help humans orient themselves within the chaos of existence. Without them, people risk losing themselves in an overwhelming and meaningless world. In this sense, the gods we create are both mirrors and maps, reflecting who we are and guiding who we might become. Even for scientists and skeptics, the archetypal structure remains. The pursuit of truth, the desire to understand reality, the drive to explore. All of these are expressions of the same deep pattern. Archetypes are not religious. They are human. Jung himself lived between worlds, between science and mysticism, between reason and imagination. His work in psychology eventually led him to study mythology, alchemy, and symbolism, not as superstition, but as expressions of the human psyche. He saw the mind not as a machine, but as a vast inner universe, filled with meaning, conflict, and transformation. In his writings, he described encounters with symbolic figures, not as external beings, but as manifestations of the unconscious. For Jung, this inner world was just as real as the outer one, and perhaps, in a deeper sense, the two are inseparable. For Jung, the question was never whether God exists in an external, measurable sense. Instead, he focused on what God means within the human psyche. In his view, the divine is an archetype of wholeness, a symbolic representation of the psyche's drive to integrate its fragmented parts into a unified whole. When people pray, meditate, or tell stories about gods, they are not necessarily engaging with an external entity. Rather, they are interacting with deep psychological structures that shape how meaning is formed within the mind. Religion, in this sense, Kiev, is not illusion. It is a necessary framework that helps the human mind navigate existence. Without such symbolic structures, individuals risk being overwhelmed by chaos, uncertainty, and existential fragmentation. Thus, the gods we create are not merely external projections, but internal maps of psychological reality. They reflect who we are, and at the same time, guide who we are becoming. Even those who reject religion entirely are not free from these patterns. The scientist searching for truth, the philosopher pursuing meaning, the skeptic demanding evidence, all are still driven by underlying archetypal forces. The archetype of the seeker, the archetype of truth, the archetype of transformation. These patterns are not religious in themselves. They are fundamentally human. Throughout his life, Jung himself remained suspended between rational science and symbolic spirituality. He began as a psychiatrist, grounded in empirical methods, but his work with patients, along with his own inner experiences, led him toward mythology, alchemy, and symbolic interpretation. He did not abandon science. Instead, he expanded its boundaries. To Jung, the human mind was not simply a network of neurons or a biological machine. It was an entire universe of its own, filled with symbols, contradictions, and hidden meanings. He recorded many of these explorations in the Red Book, a richly illustrated manuscript documenting his dreams, visions, and reflections. Within its pages, he encountered figures of gods, demons, and archetypes, not as external beings, but as expressions of his inner world. Writing the book itself became a psychological journey, an attempt to bridge the inner and outer worlds. Seen from a wider perspective, Jung's work suggests something profound. Human beings constantly create gods, but these gods do not necessarily exist above us. They may instead exist within us, as projections of meaning, desire, fear, and aspiration. Sometimes these inner gods guide us forward. Sometimes they consume us. The question, then, is not whether we create gods, but why we do so, and what these creations reveal about us. When we look at the idea of God through the lenses of science, philosophy, and psychology, a pattern begins to emerge. God is not a final answer. He is a question that keeps unfolding, one that shapes how we interpret existence itself. From the origin of the universe, to the structure of human consciousness, to the search for meaning in daily life, the same theme repeats. We are trying to understand not only the cosmos, but ourselves within it. Some argue that ultimate truth lies beyond human comprehension, beyond time, space, and logic itself. Others see divinity as embedded within reality, as the very fabric of existence. And some believe that God is neither external nor internal, but something that transcends both categories entirely. Yet regardless of interpretation, one fact remains constant. The idea of God evolves with human consciousness. It changes as we change. It reflects our deepest fears, our highest hopes, and our endless curiosity about existence. Perhaps God is not a problem to be solved, but an experience to be lived. A symbol of interconnectedness that gives depth and meaning to life itself. And as long as we have not fully understood this mystery, we will continue to search. We will build temples. We will build telescopes. We will look outward into the universe, and inward into the mind. And somewhere between the two, we may find not an answer, but a reflection. A reflection of what we are, and what we might become. But perhaps the most profound realization is this: our search for God has never been only about God. It has always been about ourselves. Every civilization has looked up at the stars and asked the same question: who are we? Why are we here? And why does anything exist at all? Science seeks answers through observation, experimentation, and mathematics. Philosophy pursues them through logic, reason, and reflection. Religion searches through faith, revelation, and spiritual experience. Although these paths often appear to conflict, they are all responding to the very same mystery. Whether we call it God, nature, ultimate reality, or simply the unknown, we are confronting the greatest question the human mind has ever faced. Perhaps that is why the debate has endured for thousands of years. Not because humanity has failed to find the answer, but because the question itself continues to evolve. Every scientific discovery changes the way we understand creation. Every philosophical breakthrough reshapes the questions we ask. Every generation inherits the mystery and leaves behind its own interpretation. Perhaps Lemaitre, Hawking, Lennox, Spinoza, Einstein, Sagan, and Jung were not trying to defeat one another. Perhaps each of them was illuminating a different face of the same mountain. One climbed through mathematics, another through theology, another through philosophy, another through psychology, and another through the language of the stars. None of them claimed to possess the final answer. Instead, each expanded the boundaries of human understanding. Perhaps the greatest mistake is believing that science and faith must be enemies. Science asks, and how? Faith asks, why? Philosophy asks, what does it mean? Psychology asks, why do we ask these questions at all? Each discipline reveals a different dimension of reality. Together, they paint a picture far richer than any single perspective ever could. Perhaps the universe is not asking us to choose one answer over another. Perhaps it is inviting us to remain curious, to keep questioning, to keep exploring, because curiosity itself may be one of humanity's greatest gifts. It is curiosity that built telescopes. It is curiosity that split the atom. It is curiosity that mapped the human genome. And it is curiosity that continues to drive us toward the edge of the observable universe. The more we discover, the more mysterious reality becomes. Every answer opens the door to even deeper questions. Every solved puzzle reveals another waiting behind it. Perhaps that is exactly how it should be. Because if the universe could be completely understood, it would cease to inspire wonder. And without wonder, there would be No science. No philosophy. No religion. No art. No civilization. Wonder is the beginning of every great discovery. So, who created everything? Was it a conscious creator? An elegant set of physical laws? An eternal universe? Or something that human language has not yet learned to describe? Perhaps the answer is still beyond our reach. Or perhaps the search itself is the answer. Because every time we ask, where did everything come from? We are also asking, who are we? And maybe those two questions have always been one and the same. The universe is still expanding. Our knowledge is still growing. And our questions continue to reach farther than ever before. Perhaps one day, humanity will discover the ultimate answer. Or perhaps the greatest discovery is realizing that the journey itself is what gives the question its meaning.